Welcome to the Deep Dive. Today we're digging into, well, a really fascinating piece of scientific history.
Yeah.
We're looking at a theory that used to be huge, but now it's mostly just a footnote. Phlogiston.
That's right. For quite some time, maybe 150, 200 years, phlogiston was really the key idea for understanding fire, combustion, that sort of thing.
Yeah, the main explanation.
Absolutely. It was the go-to theory in the 17th, 18th centuries until oxygen was discovered and really turned things upside down.
So the basic idea was anything that could burn had this substance in it, phlogiston. And when it burned, the phlogiston was just released. Seems simple enough.
On the surface, yes.
But what I find really interesting here and why we're doing this deep dive is this kind of lingering question. Was getting rid of phlogiston just normal science correcting itself? Or is there maybe, possibly, something more going on? Like, was knowledge actually suppressed?
It's definitely a provocative thought, isn't it? It makes you question if scientific progress is always this straightforward, objective path we imagine. So today, we'll first lay out the standard scientific story, how phlogiston came about, why people believed it, and why it eventually fell apart.
The official version.
Exactly. Then we'll explore the conspiracy theory side of things. What do they think phlogiston really was? Why might someone want to hide it?
Okay.
And finally, we'll circle back to the science, the counterarguments, why the oxygen theory really won out.
Great, let's jump in. So the official story first. The rise and fall of phlogiston. Where did this whole thing start?
Well, the seeds were sown back in the 17th century. There was this German physician and, interestingly, alchemist, J.J. Becher. He talked about something called terra pinguises.
Fatty Earth.
Sort of, yeah. The idea was it was the essence of combustibility. But it was really Georg Ernst Stahl, who was actually Becher's student in the early 18th century, who refined it and gave it the name phlogiston.
Okay, Stahl.
Yes, Stahl's work is what really pushed it into the mainstream science of the day.
So what did they picture? What was phlogiston, according to them, and what happened when, say, wood burned?
The core concept was simple. Phlogiston was an actual substance present in anything that could burn. When you burn wood, for example, this phlogiston substance was released into the air.
Leaving behind the ash.
Exactly, leaving behind the ash. Or if you burned a metal, what they call bakelite, which we now know is usually a metal oxide, the stuff left behind couldn't burn because, well, its phlogiston was gone.
I can see why that caught on. You watch a fire, stuff disappears, something is left that won't burn again. It feels intuitive.
It really does. It gave a seemingly neat explanation for why wood burns, but ash doesn't. It was all about being rich or poor in phlogiston.
And it explained other things too, right? Like breathing.
Yes, it did. They thought air was necessary for fire and for animals because air could absorb the phlogiston being released.
Ah, okay.
But like a sponge, the air could only hold so much. Once the air was saturated with phlogiston, the fire would go out or the animal couldn't breathe anymore.
The phlogiston sponge, I like that. But you mentioned earlier there was a problem. A big one, I imagine.
A very big one, yes. It had to do with weight. When certain things burned, especially metals during calcination, the resulting calx, the ash, actually weighed more than the original metal.
More. But if burning releases phlogiston, shouldn't the leftovers weigh less?
Precisely. That was the paradox. How could losing something make the remaining stuff heavier? It flew right in the face of the core idea.
So how did they deal with that? The phlogiston supporters, I mean.
Yeah.
They must have tried to explain it away somehow.
Oh, they definitely tried. There were some, let's say, creative solutions proposed. One of the most famous, or infamous, was the idea that phlogiston had negative weight.
Negative weight, like it weighed less than nothing.
Kind of, yeah. The idea was that it was inherently buoyant, so losing it actually made the substance heavier. It sounds bizarre to us now, but...
They were trying to save the theory.
Yeah,
right?
Exactly. They were so invested in the framework. Others suggested maybe the phlogiston particles escaping somehow caused other, heavier particles from the air to rush in, but it was all getting very complicated and, frankly, hard to test. It shows how reluctant people can be to give up on an established idea.
Yeah, that's fascinating. You see an anomaly, and instead of questioning the whole theory, you try to bend the theory or invent weird properties to make it fit. Makes you wonder.
It's a recurring theme in science history. Paradigms can be sticky. But eventually, the anomalies pile up and someone comes along with a better explanation. And in this case, that someone was Antoine Lavoisier.
Ah, Lavoisier.
Yeah.
Late 18th century, right? What did he do that finally knocked phlogiston off its perch?
Lavoisier was meticulous. He used very careful quantitative experiments. He weighed everything precisely, reactants, products, the air involved. He showed that when something burns, it's not releasing phlogiston.
It's doing the opposite.
It's combining with something from the air. He trapped the air, burned things like phosphorus or sulfur inside sealed containers, and showed that part of the air was consumed and the substance gained weight exactly corresponding to the weight of the air used up.
And that's something from the air?
He identified it and named it oxygen. He showed that calcination, the burning of metals, was the metal combining with oxygen. The weight gain wasn't a paradox anymore, it was simple addition.
So metal plus oxygen equals heavier metal oxide. Makes perfect sense.
It explained the weight gain perfectly, explained why air was necessary, explained why things stopped burning in closed containers, the oxygen ran out. It was a much cleaner, more powerful explanation backed by solid measurements. It really revolutionized chemistry.
It seems so clear-cut now, oxygen just works better. But you mentioned earlier that even with strong evidence, change takes time.
Absolutely. Scientific communities have inertia. People build careers on existing theories. Lavoisier faced resistance. Some older chemists held onto phlogiston for years. It highlights that science is also a human activity, you know? There's debate, resistance, convincing to be done.
Right, not just cold, hard facts instantly winning everyone over. But, okay, scientifically, phlogiston was clearly replaced by a superior theory. End of story.
Well, for mainstream science, yes. But this is where the narrative splits. This is where the conspiracy theory starts to bubble up.
Okay, let's go there. So the conspiracy angle isn't just scientists were wrong back then. What's the core claim?
The core claim is that phlogiston wasn't just a mistaken idea, it was real. A real substance, or maybe an energy form, that was deliberately covered up, suppressed by, well, by powerful interests.
Okay, that's a big leap. If it was real, what do these theorists think it actually was? Because it clearly wasn't behaving like Skull thought.
Right. And this is where it gets very speculative, moving way beyond standard science. One line of thought is that phlogiston was some kind of real substance or energy that was just too potent, too dangerous maybe, or too revolutionary for the establishment to handle.
Like a free energy source they didn't want getting out, or something that could be weaponized.
Precisely. Those kinds of ideas, something that could upset the economic or power structures of the time, so it had to be buried under the safer oxygen theory.
And I think I've heard even stranger ideas linked to it. Something about consciousness or life force.
You definitely have. That's another major thread. Some theorists propose phlogiston wasn't a chemical substance at all, but a kind of subtle energy, something connected to life itself, consciousness, maybe even other dimensions or realities.
Wow.
Yeah, and the idea there is that suppressing phlogiston wasn't just about chemistry. It was about enforcing a purely materialistic worldview, denying anything spiritual, anything beyond what instruments could measure, keep people focused only on the physical world.
So controlling not just science, but our very understanding of reality. That's ambitious.
It is. And then, connecting back to your earlier point, there's the more, perhaps, pragmatic conspiracy view. Phlogiston could be harnessed, used, maybe weaponized. So the suppression was simply about control, keeping this power, whatever it was, in the hands of a select few.
Okay, so we have these wild ideas about what phlogiston really was. But conspiracy theories need some kind of evidence, right? Even if it's not conventional scientific evidence, what do they point to?
Well, it's usually not lab results, that's for sure. The evidence tends to be interpretive, circumstantial. For instance, they might latch onto unexplained phenomena, things conventional science maybe doesn't have a perfect answer for yet.
Like what?
Oh, maybe certain reports of spontaneous human combustion, weird energy readings, some paranormal claims, unusual biological processes. They might say, see, science dismisses this, but this is actually phlogiston at work. It's filling the gaps with their preferred theory.
Right, using anomalies not as puzzles to solve within the current framework, but as proof of the suppressed one.
Exactly. Another tactic is reinterpreting historical experiments. They might claim Lavoisier fudged his data, or misinterpreted what he saw, or that his experiments were designed specifically to discredit phlogiston, not just find the truth.
So suggesting deliberate scientific misconduct on a massive scale.
Pretty much, yeah. Without strong historical backing for those kinds of claims, I should add. They also often point to the origins of phlogiston theory, its connections to alchemy.
Ah, the mystical angle.
Right. Since alchemy dealt with hidden knowledge, transmutation, maybe spiritual elements, they suggest phlogiston was part of that older, suppressed wisdom about reality that the purely rational, materialistic science wanted to erase.
Like it was a key to unlocking secrets the establishment feared.
That's the narrative. And tied into that are inevitably claims about suppressed inventions. Technologies supposedly based on phlogiston principles, free energy devices are a classic example, maybe manipulating consciousness, things like that that were allegedly developed but then hidden away.
Okay, so the evidence is pretty speculative, based on reinterpreting history and pointing at unexplained stuff. Let's talk motives then. Why? According to the theory, why would anyone go to the trouble of suppressing phlogiston?
The motives proposed are usually intertwined with the supposed nature of phlogiston. One major one we touched on, protecting the scientific establishment. If phlogiston was real and behaved in these radical ways, accepting it would force a complete rewrite of physics and chemistry.
Which would threaten the authority, the funding, the careers of those invested in the existing paradigm.
Exactly. It's a motive based on institutional self-preservation. Keep the boat steady, don't rock it with revolutionary, paradigm-shattering truths.
A bit cynical about scientists, but I can see the logic within the conspiracy framework.
It's a common trope. Then there's the control motive. If phlogiston was a powerful energy source or offered some way to manipulate reality or consciousness...
You wouldn't want just anyone having access to it.
Precisely. Either to prevent chaos and misuse, or, more cynically, to keep that power exclusively for a select group for military advantage, economic control, political dominance. Knowledge is power, and suppressing certain knowledge maintains power imbalances.
That sounds very familiar in conspiracy circles. Keep the good stuff for the elites.
And related to that, especially if phlogiston is tied to consciousness or spirituality, is the motive of societal or spiritual control. Suppressing it prevents people from realizing, say, hidden human potentials, or challenging established religious doctrines, or questioning the purely material basis of society. It keeps people easier to manage, less likely to seek alternative realities or power structures.
Okay, that covers the conspiracy side that claims the evidence, the motives. Now let's swing back to solid ground. What were the actual verifiable scientific reasons that phlogiston got kicked to the curb? Why did oxygen win?
It really boils down to the strength of the scientific method. First, reproducibility. Lavoisier's experiments showing oxygen's role weren't flukes. Scientists all over could and did repeat them with careful measurements and got the same results. Oxygen's behavior was consistent, measurable.
Unlike phlogiston, which needed increasingly weird explanations like negative weight.
Exactly. Phlogiston struggled with consistency and predictive power, especially with the weight issue. Second, explanatory power. The oxygen theory didn't just explain burning and rusting better. It provided a foundation for understanding chemical reactions in general, stoichiometry, the composition of water, respiration. It unlocked huge areas of chemistry.
It was just more useful. It explained more things more accurately.
Vastly more. It led to real progress, new discoveries, new technologies. Phlogiston became a dead end, requiring constant patches and adjustments that didn't lead anywhere productive.
It became clumsy.
Very clumsy. And that brings in the third point. Simplicity or elegance. Occam's razor, basically.
The idea that the simplest explanation is usually the best one.
Right. Why invent a substance with the bizarre property of negative weight when a simple explanation, adding a real gas, oxygen, perfectly explains the weight gain and fits all the other evidence? The oxygen theory was just cleaner, more direct, more logical.
So better experiments, better explanatory power, and simpler. It seems like a clear scientific win, not a conspiracy.
That's the overwhelming scientific conclusion, yes. Based on decades, centuries now, of chemistry built successfully on the oxygen model. The evidence simply doesn't support a suppressed reality. It supports a theory being replaced by a much, much better one.
Okay, so wrapping this up, it seems pretty clear the phlogiston conspiracy theory is more about fascination with the unknown than about actual scientific history.
I think that's fair. It taps into something deep in us, doesn't it? This attraction to the idea of lost secrets, hidden knowledge, powers just beyond our grasp. The thought that maybe the world is weirder, more magical than boring old science textbooks let on.
Yeah, desire for mystery, maybe a bit of skepticism about established narratives, which isn't always unhealthy, I suppose.
No, questioning is vital in science. But the phlogiston story ultimately highlights the power of the scientific method of rigorous testing, measurement, reproducibility, and favoring theories that actually explain the evidence consistently and simply. That's how we move forward.
It's a great example of science correcting itself, even if it took some time. But it does leave us with a final thought, maybe for our listeners to chew on.
Oh,
Well, we look back at phlogiston now as obviously wrong. Are there any ideas in science today, things we take for granted, that future generations might look back on as fundamentally mistaken, or maybe just deeply misunderstood?
that is a provocative question to end on. What's today's phlogiston? It certainly makes you think about the limits of our current understanding.
Definitely food for thought. Well, thanks for joining us on this deep dive into the strange afterlife of phlogiston.